Let's plunge into a simple example in which we will fire up a pod and get a running shell into the container in that pod and make sure that we have access to it. So let's get started. To begin with, let's run the kube control get pods command. This command returns an empty list. This satisfies us that at the start of this demonstration, we don't have any pods running in our cluster. So again, kubectl followed by get pods. This tells us that no resources have been found. We are working with a completely empty Kubernetes cluster. Next up, let's get started. Let's use the kubectl run command. This is a way to run a particular image on a cluster. The interesting bit about this is that we simply need to specify the image, which here is a container taken from Docker Hub, and kubectl is going to fire up a deployment object. This deployment object is a higher level abstraction which encapsulates a pod. As we can see, kubectl here tells us that a deployment has been successfully created. We specified the name of our deployment along with the image name when we ran the kubectl command. Here, the name of the deployment is first deployment. The kubectl run command is an extremely important and powerful command. It's one of the most commonly used commands in the imperative mode of kube control. In addition to simply the name of the container image, we can specify a host of other flags and options, none of which we are using here, but you should be aware that those include the port that we wish to expose our container on, any environment variables in the form of key value pairs, the number of replicas, which by default is set to 1, as in this instance, various overrides which we can do in the form of inline JSON, and various other commands and arguments for those commands. So the kube control run command is an extremely powerful one. Here we are using its most basic plain vanilla configuration, which is simply going to run a deployment which wraps within it a single replica, that is a single pod, and within that pod is going to run a single container. The image for that container is Nginx, which is pulled from Docker Hub. That's why we do not need to explicitly specify a full path. Let's now go ahead and rerun that get pods command which we ran a moment ago. This time we should expect to see exactly one pod, because our run command, the kubectl run command, is going to fire up exactly one instance of our pod, and that one instance is going to have the image running within it. Notice also how the status is running and there is one pod ready out of one pod in total expected to be ready. Lastly, notice how this pod has been alive for 12 seconds. That age field which shows up in the status of the pod can be handy. As we see, if we rerun the get pods command, we shall now get an updated value of the age. It has now updated to 49 seconds. Also pay attention to the ready field. Notice that it shows 1 out of 1. That refers to the fact that there is just one container in this particular pod, and that container is now ready. Had there been 2 or more containers, i.e. had this been a multi-container pod, that number would have been something like 2 out of 2 or 3 out of 3. Also, the number of restarts here refers to the number of container restarts, not to the number of pod restarts. So we know that our pod is up and running and it's ready for us to work with. Next up, let's get a shell, a running shell into this running container. For this, we make use of the kube control exec command. Notice here that we specify the pod name along with a couple of switches. The switch -i is used to indicate that std_in needs to be passed to the container. The switch -t is used to specify that tty is also set to std_in. The combination of exec with the -i and t switches is to allow us interactive access to a shell running inside our container. In addition to these, we can also specify a specific container running within our pod. In this instance, we can omit which container we are interested in because our pod has just the one container, and that is Nginx. So kubectl exec -it followed by the name of our pod. That name of the pod is something that we copy pasted from the result of the kube control get pods command. And at the very end is the exact command which we wish to run in order to get that shell, which here is a bash shell. So once we hit enter on this command, we notice that the command prompt changes because we are now executing every command that we type out within the environment of our container. Let's perform a few simple operations within this container. Let's echo a simple string like hello nginx, and let's redirect the string to the index.html file. This is the root location in our user share nginx html directory structure. And as a result, this string hello nginx is what any client is going to get if they hit our nginx container. Once we've redirected the string hello nginx into that file, let's go ahead and set up our container so that it also has the application curl. In order to do so, we'll first have to run apt-get update. We are running here as the root, by the way, and that's why we do not need to prefix this command with the keyword sudo. And once our apt-get update is done, we can go ahead and execute an apt-get curl. And of course, curl is a handy little utility if we would like to hit an HTTP endpoint from a command line. Because we are running this command and this pod on a cluster on the Google Cloud platform, we are effectively going to be charged for disk space and all of the other resources that we consume. So while installing curl, our environment detects that our currently set up disk space is not sufficient. And so it asks us for our permission explicitly before it goes ahead and adds disk space. Let's hit yes and keep going. The installation of the curl command now runs through successfully. We can now use this curl command in order to hit our own container. We can of course do so using localhost. Remember that when we do so, we are going to be directed automatically to the index.html page which we had just set up a moment ago. And in that index.html page, we had placed a simple line of code saying hello nginx. So let's try exactly that. Let's go ahead and hit curl localhost. And as expected, when we run this command, we see the welcome greeting which we had just inserted, hello nginx. We have successfully run our first deployment, which wraps within it a pod. We then set up a shell into this live container. This shell allowed us to execute some simple commands, and we verified that we were able to customize the content served up by our nginx container.